Do one last example here. Find the dimensions of the rectangle of largest area, so we're going to be maximizing area, you know that already, that can be inscribed in a circle of a given radius r. Okay, let's draw it out. So we have a circle, and then we're going to try to inscribe some random rectangle in it. Probably not going to be the best drawing in the world, sorry about that. And it tells me that the radius is r. Well, we're going to maximize area, so I'm going to call this x, and I'm going to call this side y of the rectangle. So area is equal to x times y. So we have our general equation. We want to maximize this. Maximize this. Well, I have two variables. I need to find a function of one variable, so I have to find a relationship between x and y. Well, I have a relationship between x and y. If I draw this little triangle here, see this little triangle? We work in red. And this little triangle right here. Well, this side is y divided by 2, and this side is x over 2. Therefore, I have, by the Pythagorean theorem, x over 2 squared plus y over 2 squared equals r squared. So I've got x squared over 4 plus y squared over 4 equals r squared, which gives me x squared plus y squared equals 4r squared, which gives me y squared equals 4r squared minus x squared, which gives me a y equal to a radical 4r squared minus x squared. This is what I plug into here, to this. Therefore, I get an area, which is equal to x times 4r squared minus x squared. Now I have a function of one variable. Take the derivative and set it equal to 0. So a prime of x is equal to this times the derivative of that. X times 1/2 of 4r squared minus x squared to the negative 1/2 times the derivative of what's inside. 4r squared is just a constant. It's 0. So it's only minus 2x plus that times the derivative of that. So we get just 4r squared minus x squared times 1. I rearrange this to get 2 and 2 cancel, minus x squared, so I get minus x squared all over 4r squared minus x squared under the radical plus radical 4r squared minus x squared. And then I find myself a nice common denominator, so I end up with a prime of x is equal to minus x squared plus 4r squared. I hope the algebra is not giving you guys any grief. I just found a common denominator over radical 4r squared minus x squared. This is the derivative. We set it equal to 0. Okay? When we set it equal to 0, of course, I have the top minus x squared. I end up with a prime of x equals, this is 0, so the denominator goes away. I'm left with minus 2x squared plus 4r squared equals 0. 2x squared equals 4r squared. X squared equals 2r squared. Therefore, x is equal to r rad 2. And again, I take the positive because I'm talking about a distance here. So x equals r rad 2. Well, we know what y is. We said that y is equal to the square root of 4r squared minus x squared, which is equal to 4r squared minus r rad 2 squared, all under the radical, which is equal to 4r squared minus 2r squared, all under the radical. That equals radical 2r squared, which is equal to r rad 2. So y is also equal to r rad 2. Now, So again, x, so I'll just say y is equal to x. In other words, the rectangle of largest area that you can ascribe in a circle is a square, where the sides of the square are equal to the radius of the circle times rad 2. That's what we have found. And let's go ahead and show you what this looks like. So I have the function, the area function that I tried to maximize, radical 4r squared minus x squared. Well, and I picked a particular value of r, radius of the circle happens to equal 2. This is the function. Well, again, x is a physical distance, so really our domain is here and here. I set the function equal to 0 to find the endpoints. Well, when I check the endpoints, when I put the endpoints into the area function, I'm going to get an area of 0. So 0 doesn't work, 0 doesn't work. However, there is a point someplace here, which we found is r rad 2. When I put r rad 2 into the function for area, I end up actually getting the largest area. And this graph confirms it. The maximum of this graph, the maximum of the area function happens at r rad 2. It happens where the derivative of this function equals 0. I hope that helped. And don't worry about it. In the next lesson, we're going to be continuing to do more optimization problems, more complicated optimization problems. Thank you so much for joining us here at Educator.com.